Welcome to Environmental Education, Education for Rural Citizens. Teaching Module 5.2, Water Resources and Water Balance for Sustainable Community. This presentation is about wastewater management in local communities. Wastewater management in local communities is a critical aspect of modern urban planning and environmental sustainability. As urbanization continues to increase, the efficient and sustainable treatment of wastewater becomes essential to protect human health, preserve ecosystems, and ensure the availability of clean water resources. This lecture explores the multi-phase challenges and opportunities associated with wastewater management at the local level, emphasizing the need for integrated and sustainable solutions. The discussion encompasses the importance of effective infrastructure, community engagement, and innovative nature-based solution technologies in addressing wastewater concerns. Furthermore, it underscores the vital role of local communities in mitigating water pollution, enhancing public health, and advancing environmental protection in an era of growing urbanization and environmental awareness. Integrated and sustainable solutions for wastewater management aim to efficiently treat and dispose of wastewater while minimizing environmental impacts and conserving resources. There are some key integrated and sustainable wastewater management solutions. Wastewater treatment plants. Modern treatment facilities use physical, chemical, and biological processes to remove contaminants and pathogens from wastewater before discharge. Reuse and recycling. Treated wastewater can be reused for non-potable purposes like irrigation, industrial processes, or cooling, reducing the demand on freshwater sources. Green infrastructure. Implementing natural solutions such as constructed wetlands, green roofs, and permeable pavements can help absorb and filter wastewater, reducing the load on treatment plants. Decentralized systems. Smaller scale treatment systems like septic tanks and package plants can be used in areas without access to centralized sewage systems, reducing infrastructure costs. Energy recovery. Technologies like anaerobic digestion and biogas generation can capture energy from organic matter in wastewater, helping to power treatment plants and reduce operating costs. Public education. Educating communities about the importance of proper wastewater disposal and conservation can reduce the burden on treatment systems and promote responsible water use. Stormwater management. Integrated systems that manage stormwater and wastewater together can help prevent overflows and reduce pollution of natural water bodies. Community engagement, involving local communities in planning, decision-making, and maintenance of wastewater systems can build a sense of ownership and responsibility, leading to more sustainable practices. Resource recovery. Recovering valuable resources like phosphorus and nitrogen from wastewater for agricultural and industrial use can make treatment process more sustainable. International cooperation. Collaborating with neighbor regions or countries to address transboundary wastewater issues and ensure sustainable management of shared water bodies. Nature-based solutions are environmentally friendly and sustainable approaches that utilize natural processes and ecosystems to manage wastewater and improve water quality. Here are some examples of nature-based solutions for wastewater treatment. Constructed wetlands. Constructed wetlands mimic natural wetlands ecosystems to treat wastewater. They use aquatic plants, microorganisms to remove pollutants, making the water cleaner before it's discharged. Living shorelines. In coastal areas, living shorelines use vegetation and natural materials to reduce shoreline erosion and filter contaminants from wastewater before it reaches natural water bodies. Riparian buffer zones. Riparian buffer zones are vegetated areas along the edges of rivers and streams that help filter and reduce the impact of pollutants from wastewater runoff. Bioretention systems. Bioretention systems, such as rain gardens and bioswales, use a combination of plants, soil, and engineered systems to capture and treat stormwater runoff and wastewater. Reed beds or reed ponds use reed plants to absorb and break down pollutants in wastewater, improving water quality. Green roofs. Green roofs are designed to capture and treat rainwater, reducing stormwater runoff and providing some level of wastewater treatment through the vegetation and growing medium. Algal ponds. Algal ponds utilize microalgae to absorb nutrients like phosphorus and nitrogen from wastewater, providing a natural form of nutrient removal. Riverbank filtration. Riverbank filtration involves the passage of water through riverbanks and natural sediments to remove contaminants, improving the water quality of water before treatment. Soil infiltration systems. These systems use natural soils and vegetation to filter and treat wastewater from septic systems and decentralized wastewater treatment facilities. Floating treatment wetlands. Floating islands or mats are made of vegetation, can be placed on water bodies to absorb nutrients and pollutants from wastewater. In summary, this lecture explores multifaceted challenges and opportunities associated with wastewater management at the local level. It emphasizes the need for responsible wastewater management, conservation, and pollution control, especially in the context of climate change. Special emphasis is given to the superior effect of nature-based solutions for wastewater treatment. Thank you very much for your attention.